In this video, we're going to talk about esters. And esters were really discovered in the 1800s in willow bark. And I say discovered, and I mean that by Western science. And of course, kind of Native Americans has been using esters for many, many, many centuries prior to that. We've been using it in willow bark and also in something similar to it in the form of wintergreen oil as pain relief. And we'll talk about that in some depth later, hopefully in the next week or so. But this particular chemical, salicylic acid, is really the active component of aspirin. And we'll see that something even quite similar to that as well in wintergreen oil. We'll hopefully be able to distill that out of wintergreen leaves ourselves and do some reactions with that, hopefully. So esters are synthesized from the reaction of carboxylic acids and alcohols. They are also found in fats and oils, and they're really good smelling. They're responsible for the aromas of bananas, oranges, strawberries, and those flavors. They're responsible for the smell of wintergreen and spearmint. And so this reaction of esterification is the idea of taking a carboxylic acid and an alcohol and mashing them together. And so if we start with a carboxylic acid and an alcohol. So we're starting with ethanoic acid and 1 propanol. And what we're going to do is we're going to take the OH from the carboxylic acid and the H part of the alcohol, and we're going to get rid of them, and we're going to make water. We're going to join those two out. We're going to pull them off. We're going to make water. And so the remaining carbonyl from what was the carboxylic acid and oxygen from what was the alcohol, those are going to join together along with all the carbons, the rest of the backbone, and everything else, the rest of the backbone and everything else from those chemicals are going to come together to form an ester, my ester product. And this is that really good smelling, tasting product. Here's my ester. So an ester then has a carbonyl next to an oxygen, but these are surrounded by carbons. So again, we've taken a carboxylic acid and an alcohol, pulled out of water, and joined to form an ester. So let's go to the whiteboard and see what this reaction looks like. So I'm going to start with ethanoic acid. It's a pretty simple acid, carboxylic acid. And this is going to be done in an acid catalyst. And our carbonyl oxygen is going to attack the hydrogen from our acid. Our chlorine here, our leftover chlorine, will just be released as an ion with the electrons from its bond. And our intermediate will have a positively charged oxygen. Okay, so of course this is unhappy. We don't want to have a positively charged oxygen, right? And so we do have, of course, this alcohol floating around, and I'm just going to use methanol to keep it simple. So just methanol, CH3OH. And it's got some electrons, so it can attack this double bond. Electrons from the double bond can go and sequester that plus charge. And so now we will have a intermediate that looks like this. Original OH here. And we've brought on a new OCH3. But now this new oncoming oxygen with the new alcohol is unhappy. It's got a plus charge on it, 3 bonds, unhappy. So something's got to give. Well, we happen to be in water. So water can go ahead and attack the hydrogen that was from the acid. The bond here that held it on will go ahead and attack back onto what's going to now be a double bond. So there was a double bond here. Now there's going to be another double bond here. We do a little bit of an arrangement, or a rearrangement, I should say, where we're going to convert this to a good leaving group. So we're actually going to steal, and without getting even deeper than we have to, we're actually going to, in this step, steal this hydrogen and put it over here. So now we've got a good leaving group. So the transfer of a proton from one oxygen atom to another will yield a second tetrahedral intermediate. So we're just making a really good leaving group. So we're making a water here so it can leave. So it's just a hydrogen rearrangement. So make a good leaving group. So that this unit has left to become a water. We've now got a double bond oxygen. And the hydrogen that was on our alcohol oxygen has left with that water. So we did a hydrogen rearrangement. So loss of a proton and expulsion of water regenerates our acid catalyst and gives our ester. So this step is a little bit wonky. It's just a hydrogen rearrangement. So we've moved this hydrogen over. It looks a little bit weird. I understand. That's okay. This water has stolen the red hydrogen. This hydrogen has moved over to pop off with the OH to make a water. So we've got an H3O plus up here, a water down here, and an ester here. Okay. In our next video, we'll come back to talk about the properties of esters, how to name them, and then a couple of reactions that they undergo when they break back down into carboxylic acids and alcohols.